Hey, how's it going, everybody? This is Courtney. I'm here to go over a new topic that I've been studying. It's not really new, but just a topic I wanted to share with everybody. One of the things that I kind of wanted to start doing as I start going through my CCIE studies is as I learn about different things, I'll go ahead and create videos and presentations just to kind of share the new information that I gained from it. Um, this is something I kind of suggest for everybody to do. Um, it's not many cases that we're able to where we have the opportunity to be able to share the information that we gather with anybody. And so, if you do something like this, not only is it helping strength, helping the person or the listener to obtain this information, but also to help strengthen you yourself, because as you're regurgitating it, you're constantly reinforcing what you just learned, read, or watched the video on. So this is something that I totally encourage anybody doing for any new topics that they come across and want to start learning. Um, so let's go ahead and dive deep into it. So like I said, this topic is going to be over ISIS, which stands for Intermediate System to Intermediate System. Go ahead and start the slideshow here. So some basics of ISIS. It's defined in RC 1195. The term intermediate system, it refers to a router. Let's see, it uses the connectionless network service via the connectionless network protocol for transport. So what this means is it actually uses the OSI reference model for actual header creation. It doesn't rely on TCP/IP like most routing, well, like all your other routing protocols. ISIS is special in that case. It does not require a circuit to be established before data is transmitted, which is very similar to RIP. And when I say that, don't take that word for word, but essentially, whenever you put in a network statement where you compare OSPF and RIP and EIGRP, with RIP, it doesn't maintain a neighbor adjacency. So as soon as you put in a network statement for the subnet that you want to start advertising, um, whether a network is available on that, you have to use it'll actually start sending out the RIP messages to whoever is listening on that segment. So it doesn't require you to actually have an adjacent neighbor. So ISIS kind of operates similar to that. It's not relying on TCP, IP, unlike other IGPs and BGP. So when I say that is, it means that you don't actually have to have an IP address assigned to the interface before ISIS can start exchanging messages. The neighborship, since it works off of the CLNS and using the CLNP protocol, IP addresses and TCP/IP is not needed, unlike any other routing protocol. Since EIGRP, BGP, and RIP all rely on IP, if you don't have an IP address configured on the interface, none of those protocols would actually work. So that's one benefit of ISIS. Really comes into play. Say that somebody goes and mistakenly disables or wipes off an IP address from the interface. It doesn't break the ISIS control plane. Now, what would happen is because of ISIS handling IPv4 routes, it will break the data that may have been flowing over that connection, because now the link state database no longer contains that prefix that would have existed on that interface for transit. But the actual ISIS control plane will not break. So that's kind of a cool added benefit of it. Supports IPv4 and IPv6 address families. Uh, it's similar to OSPF and link state operation with minor differences. And when I say that, the minor differences really comes into the SPF calculation. That's very, very much the same. It actually uses the Dijkstra algorithm to calculate the SPF tree. Um, there is major differences in operation, of course, with ISIS. One of those is that it does not adapt to the concept of backbone area or area zero. As we all know, OSPF relies on area zero for inter-area routing. Um, if you have multiple areas like area 2 and 3, and they're discontiguous to, or they're disattached from area 0, those areas will not be able to communicate with each other unless you have an interface talking to area 0. So that's one of the cool flexibilities that you get with ISIS. The device belongs to an opposed. The device belongs to an area opposed to the interface, and what that's saying is with OSPF, whenever you do the network statement or you go into each interface and enable a routing process, that particular prefix or that particular interface becomes a participant in that area. With ISIS, the actual entire device or the intermediate system is in an area. So if you have 3 routers and 3 routers are configured with area 0 or area 5 or whatever area you want to use, though the entire device, every interface on that device belongs in that area. It uses the concept of level 1 and level 2 topologies. So with that being said, that's kind of the replacement for, I don't want to say replacement, but that is one of the different major differences is that since there is no a concept of backbone areas, ISIS uses a level approach. So level 1 is for intra-area routing, and level 2 is for domain or multi-area routing or inter-area routing. So if you have multiple areas, the circuit types or the adjacencies that you would need is going to be dependent on what you want to do with your communication. We'll actually see some pretty cool things when it comes to area definitions or defining areas for a device and how that all works with the different area options that you have. Devices can be configured as level 1, level 2, and or level 1 and 2, uh, depending on, like I said, whatever your topology is that you plan on implementing, or whatever the network that you plan on, or whatever your design is, or your design goal is for your network, and multi-area support. So we'll go into more. I have a slide that kind of shows what I mean by that, as far as having a single device in multiple areas and how you're still able to form adjacencies and traverse across areas with a single device. It's something that I kind of had a misunderstanding on until I did it in a lab, and it was actually a pretty cool um, concept of how it actually is implemented and how it all works. So I'll go into more details on that on a later slide. Um, so the multi-area support, like I said, the use of multiple areas in a single intermediate system will cause the link state database to be synonymous. Once again, I'll show you exactly what that means if that sounds like another language to you. Um, but where you would see this is that if you have an ISP merger and 2 network entity titles, which we'll get into what that means, can be configured with area IDs, with different area IDs. This allows the link state database to synchronize and allow a phased approach of area consolidation. And like I said, I have a whole slide that actually is dedicated to just this multi-area configuration, which I think is probably one of the coolest things about ISIS. Okay, so we'll go into level 1 routing. So like I said, it defines your intra-area routing. It utilizes identical link state databases. So everybody within a specific area using level 1 circuits will have the same topology table as everybody else participating in that area. When level 1 only devices are connected to level 1, 2, or level 2 only devices, it operates similar to an OSPF not so stubby, totally stubby area router. And what that means is that if you have a level 1 only device connected to a device that has a level 2 circuit, what's going to happen is, like with OSPF, not so NSSTS routers areas, is that typically you only will have your LSA type 1 and type 2 entries inside the routing table, which means your intra-area routes, and all inter and external routes are replaced with a default route by the ASBR or the ABR. So that kind of happens with, it's the same thing that happens with your level 2 devices. They'll actually generate a default route that would get propagated through the level 1 connections, so that way the level 1 guys have a way to route outside of the domain. And that goes over for what I was speaking about on that. So level 2 routing, interdomain or inter-area routing. meaning crossing different area domains. Uh, Level 2 devices act as border systems between level 1 areas, allowing level 1 only devices to be the ability to traverse area across area destinations. All right, so we'll get into the ISIS address format. So as an intermediate system is identified by something called the network entity title, or the NET, what I mentioned earlier. And essentially the NET is it's similar to a router ID for like OSPF, EIGRP, but it's not tied to a layer 3 IP address. Like with OSPF, EIGRP, typically what it'll do is once you start the process, because it needs that for operation, it'll automatically grab an IPv4 address. On if you have a loopback address, it'll grab the lowest loopback number or whatever available interface is at that time. ISIS, since it doesn't rely on TCP/IP or it doesn't even use TCP/IP for transport, the net is actually what is configured for its router ID, but it's not just the router ID; it's contained within the router ID. So it has three parts: the area ID, which is actually the identifier for what area the device is participating in. Um, the system ID, which is going to be the unique identifier for the intermediate system or the router. And that's actually the router ID portion of the net. And then you have your end selector, which is it must be set to 0. It's something that the ISIS process uses internally. And I want to say it has to do with your DIS election and circuit names. But um, whenever you're configuring the net, you don't ever set anything but double zeros. Um, a sample address of what a net looks like. You have the three portion. Uh, and so the first half of the net, as you can see, I'll grab my pen here. This here is actually your area address, which is a variable length area address, meaning that not all bits will be used, but this piece of the address is what represents the area ID. And then this piece of it will represent your system ID, which will be the unique identifier of the system itself, which is a 6-byte field, or 6 bytes in total. And then your net selector is these last two fields here, which is used for ISIS internally. So it's not something that you go and set yourself. So let's go ahead and get into ISIS PDU types. I'm trying to keep the videos to about 15 minutes apiece, so I'll actually pause and you guys can go to the next video here and we'll go ahead and pick up from this screen.